Fine. So I was just discussing about how this information retrieval process is challenging in different big data scenario. So I already explained about the data at rest part. So now I am taking the another aspect like data in motion part. So as discussed, like when we talk about data in motion, so it is all about dealing with the streaming data. Okay, so where the repository is continuously updating. So to deal with the streaming data, there are certain arrangements which we need to adopt. So one of the arrangement is identification of windows. So windows are basically taking some finite subset of the data elements over the infinite sequence of data. So you can see here in these particular slides, there are variety of windows like count based window where we are taking only four documents at a time just to have the retrieval part. And you can see there is a time based window. So in time based window, what we can do, we can simply take certain time stamp or time interval, or according to the availability of that time interval, we will process the uh, particular elements. And similarly, there are sliding window concept. So sliding window concept means every time we will forget one last element and we will include one new one. So in this way, the sliding window, basically it will slide where we are gradually forgetting the older elements and we are incorporating the place for the new elements. So there are different ways of maintaining this data stream for observation with the help of window techniques. So there is one another thing which we have to take care, like whenever we do the information retrieval part, mostly at the time of information presentation part, we perform some clustering and or classification kind of task, so that whatever data or whatever documents we are presenting, that can serve the purpose in more meaningful way. So for that purpose, for that particular phase, these streaming data is really a challenging it means a challenging issue. So I am explaining this challenge with the help of these particular representation. So you can see that there are various data elements I have shown with some color coding. So it is basically T1, T2, T3, T4. They are the time stamps. So anytime T1, if the data is dynamic in nature, it will update for the time t2, and again it will update for the time t3, and so on. So basically this means every time you are getting a new data instances. Okay, and these new data instances are maybe different from the previous one, and you can see after period of means after some time, there is a possibility of complete change. So if you compare this t1 and t5, there is a complete change. So if this is the type of data which we are dealing, so that last stage, that is to maintain the model performance, may be really a tedious job. So if we have learned the classification or clustering model with the help of this particular data, and so this is, if suppose this is our training data, then how to make a good prediction if the testing data is nothing but this one. So this is basically a challenging task. So while dealing with the information retrieval stages, especially that last stage, that is the presentation stage, it is very difficult if we deal the if we are dealing with the streaming data or dynamic data. So here definitely we need to see certain ways for model adaptation. Otherwise, it will show poor performance in terms of the expected outcome. Okay, so this particular characteristics is actually named as concept drift. So concept drift is a possible you can say the variation where the same feature vector is representing these different class levels, maybe after maybe later or after some time, or with some different probabilities. So basically it is nothing but change in the concept, so that we need to address. I can show you this simple example for better purpose. So suppose we are dealing with some information retrieval task where ultimate goal is to show certain kind of classification of these samples. Maybe positive sentiments means they are representing the positive sentiment or negative sentiment. Fine. And there we identified that this is the hyperplane, successfully show the positive and negative sentiments at time t. So when there will be a next time stamp, maybe at time t plus 1, the as per the nature of the data, the distribution will update. So once the data distribution will update, you see this previous classification model become obsolete, and now we need to update our plane also, separation plane also. So this is the way how we need to update the separation plane or the model for the purpose of better sentiment classification. So the concept drift problems are really one of the very obvious and natural problem, but still difficult to handle under the different stages of information retrieval processes. So that we have to incorporate. And okay, so that is all about the concept part or the challenges part, which we have to take care in terms of getting a more appropriate methods of information retrieval. I want to highlight two options which are established as a two different technology for the two scenarios which I am taking. So first one is data at rest part. So whenever we are doing the information retrieval for data at rest, I would recommend Hadoop environment where we can do batch processing, where all the data is assumed to be available at once, and we can perform all our various stages without having any hurry or difficulty, and maybe we can repeat the process again and again for but better learnability. But they so this is basically the disk based computation. So here we have ample amount of secondary memory available, disk memory is available, and we can use that. And we can maintain the repository of any size, so that there is no limitation in terms of maintaining the repository of the document. The another option which is available, that is in memory based disk calculations or computation. So for that, the Spark is recommended. So we assume that Apache Spark is capable enough to handle very small or micro batches, or maybe it can handle the streaming data without any delay, because it is not using the disk space for computation, but it is using the in memory features of the commodity hardware which we are using. So basically it is doing all the task in the random access memory or main memory of the particular system. So these are the two varied way of working with the information retrieval task while dealing with the data which is at rest and while dealing with the data which is in motion. So now I am coming to the implementation details, like how it is possible. So basically, there is a in big data Hadoop ecosystems are really very rich, and there are various components, and a few components are highly dedicated for the information retrieval process. But overall, these Hadoop ecosystems can serve the purpose at different stages of information retrieval process. So I'm not going in much detail, but yes, Hadoop is in picture from 2006 onwards. And basically, it is an open source data processing and storage platform. Okay. And basically, it is originally written by Java, but now it supports scripts written by Python, Scala, and Java all. Okay. And the main feature of this Hadoop is it is having a distributed file system. So basically, whatever we are processing in terms of file, it can able to distribute the file in among thousands of nodes, maybe a fraction of second. So you can imagine the means how you are going to reduce the latency. And this distributed processing is actually a parallel sorry, it is actually the concurrent execution of the task. So without any delay, you can get your task whatever earlier it was expected to do with one machine, and now we are dealing with maybe thousands of nodes at a particular time. And so if we this is the kind of platforms which we are expecting. So all the necessary support to manage these platforms are already available with the Spark, sorry, with the Hadoop. Suppose we want that there should be reliability, So there are better replication mechanism. Suppose we want that there should be proper support system so that we can maintain this distribution clearly. And so basically these all things are already available in the Hadoop ecosystem. So I will explain. So it supports everything which is required for a typical information retrieval system. So it can give us a way where we means it can give us a platform where we can keep all the files or data repositories if it is at already available to us. So if the case is data at rest, it is going to provide us all the supporting mechanism so that we can store our file. Okay, and at the time of file storage, it will give all the utility features like to show to handle the failure cases and to handle the data loss cases. And then whatever repository we are going to manage under this particular case, it is going to provide us enough scope of distributed as well as concurrent execution so that it can overall expedite the process with maximum throughput. Okay, and the another part is, suppose at any stage, it is not only the case of distribution of the particular computational task, but if we want to scale the computational parameters, so that is also possible with the help of Hadoop. So there are many companies, they are by default using Hadoop. So there is it is not news nowadays, because everywhere you can see that Hadoop features are utilized. The best part of this particular Hadoop environment is it can use a commodity hardware. So there is no need to have very high configuration computer systems. So we can make a collection of some very normal computer system with minimal specifications, and that can serve the purpose because they all are coming together to serve us as a form of cluster. So there are different ways of using it, like standalone mode, where we can use only single instance. So only one node will be there, one machine is there. There are fully distributed mode, mode where multiple machines with multiple nodes can connect together to form a Hadoop cluster. And all the cluster management is supported by Hadoop, like how to make the job tracker and how to make the master nodes or how to make the slave nodes. So everything will be available through the Hadoop cluster support. Then there are pseudo distributed modes. So pseudo distributed mode means within particular node, if within a particular machine, if we can create more than one nodes, and if we can see how these processing of concurrent task is executed, so that is also fine with the Hadoop pseudo distribution mode. So this is all about the Hadoop ecosystem. So if we summarize the information retrieval steps in some very abstract way, so basically we need to means collect the data, or we need to have the data acquisition system first. And once the files or data is available to us, then there are certain kind of pre-processing required, and this pre-processing is to understand what kind of information it is holding, and finally later we need to summarize these informations as per our desired criteria. So if this is the three important stages, so these three important stages can be very efficiently served by the Hadoop ecosystem. So suppose if we talk about the data ingestion part, means how to collect the data, how to retrieve the documents, how to identify the documents. So here you can see that there are two features. One is the Flume, second is the Scoop. Okay, so these Flume and Scoop, they are basically data ingesting services. So with the help of Flume and Scoop, you can basically collect or gather data as per your requirements. So Scoop is basically for the structured data. So whatever relational database management systems or tables you are having, that can be gathered with the help of a Scoop. And if suppose anyhow we are working with Twitter data, which is unstructured type, or we are working with some semi-structured data, or if we are working with the data which is available with real-time application scenario, so for that Flume is the best. So with the help of Flume, we can generate the stream, we can acquire the stream for further purposes. We can decide like means there may be an actual speed of data arrival. We can create certain buffer, a very small time lag buffer, so that that arrival can also get controlled at our end, so that we can do the efficient operations. So that is basically the first part. The next part, it comes to the storage. So storage, so whatever data we want to store, so most of the time what we do, we create certain kind of indexing, whatever information we are dealing with, and that indexing can help us for better searches. So here there are the options of HDFS, that is Hadoop distributed file system. So Hadoop distributed file system provide us very strong support to keep the data within the Hadoop environment with all possible support. So even with the help, so basically it is providing us a distributed support. So here what we can do, if we are having huge amount of data availability, maybe we are dealing with uh, n number of documents. So these documents, with the help of Hadoop distributed file systems, they can be placed maybe at once if the size is not an issue, or they can be placed in multiple machines or multiple nodes if we are dealing with some limitations of the hardware availability. So basically it provides us lot of distributed processing support to process further in an efficient way. Then you can see at this particular stage we have various kind of supporting mechanisms. Like for example, you see here there is a map reduce, that is processing using map reduce environment. I will discuss it. So map reduce environment is just a way of writing programs in such a way where we assume that a job can be divided into multiple subtasks, and these subtasks can run independently. They may be parallel in nature, they can run concurrently over distributed machines. So this is basically supported by the map reduce. Similarly, if we see like whatever data or documents we are handling, there are Hive and Drill. They are SQL kind of query supporting platforms. So they give enough enough query formation platform so that we can prepare the queries as desired for the particular application, and they work at the top of the Hadoop HDFS. So whatever distributed storage you are exploiting with the help of Hadoop, the same distributed storage can get further means utilized by having the strong support of Hadoop and Drill. Similarly, we have this is Spark. So Spark, as I have already told you, like generally the map reduce is for disk based computation, where we assume that everything is available at once. This Spark is the in-memory computation platform, where we assume that the particular documents or the repository, it is coming in the form of stream. So basically it is supporting us in memory data computation. Then we have another data acquisition tools and a little bit more better management for streaming, that is Kafka and Storm. So basically Kafka and Storm is helping us to have better stream management. Okay, then you can see here there are Apache Spark mlib libraries. So these mlib libraries, they are having all pre-processing tools. If it is a case of data streaming, then whatever streaming related pre-processing is required. For example, like if you want to see the window size, or if you want to see the means their what I can say, that the way how to detect the concept drifts, and accordingly the way where we need to update our model. So everything is available with the Spark mlib libraries. Then there are many supporting services. For example, if we want to perform some search uh, in certain repositories which are following the HDFS format, so there is a very dedicated searching and indexing mechanism, and that is very popular in information retrieval systems, that is Solar and Lucent. So they are basically a way to search among different documents to get the desired result. And if sometimes we are dealing with a certain data which is not having the conventional structure, so for that also we can utilize it with the help of pig or hbase. So basically pig is the kind of strict scripting language. With the help of small script we can available we can make the document process. So other than this, being a overall manager, these zookeepers, Apache, Ambry, and OZ, they are responsible for all distributed environment management, maybe naming criteria, maybe allocation of nodes, then deallocation of nodes, and they are also taking care of scheduling features. They are also taking care of provisioning, monitoring, and maintaining of the overall cluster environment. So this is all about the Hadoop ecosystem. And according to situation, maybe for data at rest part or maybe in data in motion part, I think this Hadoop ecosystem is having the most powerful available features nowadays to support various information retrieval techniques. So I am giving one example of MapReduce, how MapReduce is helping us to calculate TF-IDF, or how MapReduce can help us to process 8 different stages of document processing. So that can be understood by the MapReduce paradigm. So actually, in a very brief way, what we can understand, like MapReduce is a programming model proposed by Google, and it is having two keyword. Basically they are the two function, one is the map and second is the reduce. So these are the two important function, and the core purpose of using MapReduce is to parallelizing the computation across large clusters of machines or clusters of commodity hardwares in a very reliable manner. So basically if you are using 10 small computers, so you can divide one lengthy job among 10 these small computers, maybe they are the part of the cluster, and finally after utilizing their processing capabilities, you may retrieve their individual results, and finally you can present the cumulative uh, computation. So that is basically possible. Other than this, all the means overheads, for example, like maintaining the reliability part, observing the machine availability, maintaining all cluster functionalities. So this is all basically supported by the Hadoop MapReduce programming. So we can customize certain means environment for our purpose. So I'm not going in much detail here. I am proceeding further to explain like how MapReduce will work. So basically for MapReduce environment, there are 4 phases. One is the splitting phase, the second is the mapping phase, third one is the shuffling, and fourth one is the reducing phase. So I'm taking a very means most fundamental and conventional example of word count here. So suppose the input data is nothing but it is a kind of text file where we are having this input data like welcome to Hadoop class, Hadoop is good, Hadoop is bad. So basically it is a text repository which is available as an input data. So the final output of the MapReduce is expected in terms of a word count. So basically it will see all the words, whatever is the available, and then it will support us for the with the word count results. So what we can do according to the, okay, I'm going for the architecture part first. So you can see that whatever input files are available, it will equally distribute all the input files in multiple splits. Okay, so once these splits are done, then these splits may be given to the worker nodes. So basically the worker nodes are the actual executors of the task, and these worker nodes are managed by the master nodes, and master nodes are managing the task allocation and deallocation techniques, and they are also taking the contribution of individual workers and finally creating the complete picture. So actually the distribution of task to the worker is the mapper phase, and these workers are doing some of the computational contributions. Okay, later recollection of the computational aspects from all the workers and showing the cumulative picture is the reduce phase. So basically there are different phases we can say. So one is the mapper phase and second is the reducer phase. I think I can explain better with the help of this particular diagram. So here the map reduce architecture says that whatever text input we will receive, it should be properly splitted, and there may be some splitting criteria. So we can define the splitting criteria as per our need. So here we have taken like maybe the 3 words per node. So we have taken 3 words per node, and then it has to be given to the worker nodes for mapping operation. Okay, so mapping operation is nothing but to calculate the frequency of the each word in a particular document, means in a particular split. So basically we are calculating here like welcome is coming one time, to is coming one time, Hadoop is coming one time. Here I want to say that means the typical IR techniques like removing the stop word and some other aspects, it is not shown here for the in that aspect, but still if we want we can definitely assign different workers to these relevant kind of tasks. So that can be done as a part of pre-processing here. So mapping function is to have the count of the individual words in a particular split, and once the mapping has been done, there is another phase which is a shuffling phase. So in shuffling phase, what we are doing, we are summarizing the results of the different mappers under certain common criteria. So we are shuffling this in such a way so that the similar tasks can be grouped together and all distinct class can be kept separately. So this has been done, and there is a next phase, that is the reducer phase, and in this reducer phase we are taking the collective picture of all the similar tasks which are grouped together. So in reducer phase, you can say like Hadoop was repeated 3 times. I think Hadoop was in these 3 splits. So that's why it is appearing here 3 times, and finally we are having the count 3 for the Hadoop. So this is showing the final output of MapReduce function. So it is a simple word count function. What is actually going on in background, basically whatever input we are receiving, uh, 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 if we imagine the situation of big data scenario, we can imagine its size. So for that, these kind of splits are really helpful because they are going to give us a distributed processing environment which can run by various nodes and which can be run concurrently, parallelly together, and finally we will get the data with very minimum time lag or maybe real time way. So this is the way how it works. Here I want to quote this, like in MapReduce environment, we are actually working in disk-based computation. So it is not claiming that it is an actual real-time task, but yes, some delay is there, but definitely it is very much powerful in terms of the computational capabilities. So this is the picture of MapReduce architecture, and showing the world where we are dealing with various issues of information retrieval processes. So these are the 4 phases: input phase, split phase, mapping phase, shuffling phase, and reducing phase. Okay. So this reducing phase is actually summarizing the complete outcome. So that is important. And shuffling phase is actually the dealing with the frequency count and taking the complete picture of this. And this mapping phase is nothing but it is the actual count phase. So these are the 4 phases of the MapReduce. So that is important. If I go with this architecture part, so you can say that since it is managing the distributed environment, so there are job trackers, means basically there is a job tracker. So job tracker is responsible for creating all the data nodes, or means task distribution. So here you can see that there are 3 data nodes, so there may be 3 parallel tasks can be executed. So that is basically possible here. Okay. So if we go for the nomenclature, so I think it is clear, like the job trackers are, they are the managers, and task takers are the actual workers, and they are working for their own part in terms of the splits which they are getting for the execution. Okay, so I think we can proceed further. So if we see the information retrieval task, so which task is very closely fit with the map reduce environment. So that is basically TF-IDF calculation. So this is something which is the first thing if somebody starts learning the information retrieval using map reduce paradigm. So basically here what we need to calculate the number of times the term X appears in the given document, the number of terms in each document, the number of documents appears in the particular document, and total number of documents. So these are the things which we are really interested to know. And with the help of MapReduce paradigm, this can be easily possible. So basically what we need to prepare the functions like mapper functions and reducer functions. So mapper functions is basically to manage the split part and the count part, means the shuffle part, and reducer functions are basically to summarize the complete results. So sometimes it means in a very simple operations, it is simply a count operation. So it will summarize the counts for the words in a particular document and then take the complete picture. So basically it is divided into 4 jobs. One is the word frequency in a doc. So that can be possible with the mapper and reducer. The second one is the word counts for the particular docs. So that is also available with the help of mapper and reducer function. So we can prepare the mapper and reducer function for it. Third is the word frequency in the overall corpus. So that can be also counted with the help of mapper and reducer representation. And we can also see calculate the TF-IDF based on this. And again, it is basically with the help of mappers and reducer. So individual mapper will give the individual score, and finally we can means individual parameters, and finally we can calculate the total value of the function with the help of a reducer. So I can demonstrate the map reduce function at the end of this particular session. Means there is a small video which can be shown to you so that you can understand. So now the question is like, what are the challenges here? So the challenges, as I have already told you, like we have to go for better and better indexing mechanisms so that we may eliminate the efforts which is required, and we can go for the perfect matching. Then there are the retrieval related issues, like we means it is not means good to have more results, but it is good to have the less result. It means less but more accurate results. So that can be enhanced by using the computational capabilities of MapReduce. And the third one is the sorting problems. So whenever we are having enough documents and if we are trying to sort them under certain order, so the question is like how it is possible to sort if we are already aware that all cannot be available at once. So basically there are some dynamic mechanism has to be adopted. So there are these kind of various important issues that we can solve with the help of MapReduce as well as the other Hadoop ecosystem components. So that I will demonstrate here. Okay, before going to that, I can show you the very basic example, like how to calculate the inverted index TF-IDF with the help of mapper and reducer function. So there are 4 documents you can see. They are having certain statements, and you can understand that we can do the TF-IDF calculation with the help of certain matrix kind of arrangement. So that is already here. We have highlighted like term frequencies and document frequencies for this particular word. And then with this, what we need to do means we can prepare more and more better indexing if we are going ahead for the positional index. So here you can see that here we are not only showing that how many times the word is occurred in a particular document, but we are also highlighting its position. So basically position is also very important, which we can highlight. So in document number 2, the blue is coming at the 3rd position. So that is highlighted here. Okay, so document number two, it is coming one at one time, but maybe in third position. So this is the common way of inverted index preparation, which we generally do. But the question is how to make it in terms of map reduce. And you know the purpose. So map reduce is used to have the scalability. So whenever we are doing this indexing part, it is not the matter of few lines or few documents or few files. Maybe we are dealing with millions of documents together for a single query match to be matched. So basically scalability is really very critical. Okay, so basically we need to work with the relatively faster way, and sometimes it may be real time required or sometimes may not be real time required. Here for a typical map reduce operations which is using the Hadoop environment, we are assuming that real time is not at all required. Okay, so how we can do, we can make it in a better batch processing way, and sometimes if required, that batch can also be incrementally updated. Okay, so these are the things which we can solve with the help of the map reduce. And means all these expectations, they are better solved with the help of map reduce environment. Okay, so I'm going to show you the mapping and reducing contributions. So here you see the job is divided into various parallel files, you can say, means the splits. So we are assuming that there are three mapper functions. So one is for doc1, doc2, and second is for doc2 and doc3. And these mapper functions, they are individually counting the occurrence of the words in okay. So there may be n number of mapping functions, and as I have already told you, these mapping functions may work with different nodes. So it is basically scalable and it is basically distributed. So you can see that there will be unlimited computational opportunities. Once this mapping function will be done, then we can go for the reducing function. So reducing functions are basically followed by shuffle and sorting kind of arrangements where we take the conclusive picture in terms of some kind of summation or in terms of some kind of summarization. So this is the pseudo code for the inverted indexing. It is actually using two classes. One is the mapper class and one is the reducer class. And we are using associative array for this. And for every time we are including individual items and we are mapping it with the separate mapper functions. So mapper is basically, it is taking some individual elements and it is doing the task that is in terms of some count. Then we have the reducer function. So reducer function is taking the cumulative picture and then it is creating a new list where it is taking the cumulative picture as an appended list. And finally the sorting is also the responsibility of the reducer function. So basically if we go in a variations of this mapping and reducing, so functions, mapping and reducing functions, so sometimes you see that the positional indexes can also be well addressed, where we are saying the position of each component. So this is basically document representation, this is the frequency representation, and this is the position representation. So one is coming with document number one with one time and its position is also one. So this is the way where we can have the modified mapper functions where it is showing the positional indexes also, and same with the reducer function. So reducer function is also showing the cumulative picture with positional indexing. So so here basically we are posting it with the help of the positional indexing. Okay, so this is the way how to create the mapper functions and reducer functions. So for any particular example, basically we have the for mapper function we have required the term ID and the document ID, and for reducer function we are creating the term ID and the list of the document IDs. So basically this is the way how we develop the map reduce functions for getting this TF-IDF calculations. Okay, and you can see the scalability part here. So the scalability part is like we can do the partitioning. One is the vertical partitioning and second is the horizontal partitioning. So we can see that in any document how many times the particular term is there. So basically we are doing the term partitioning here. It is a kind of horizontal partitioning, and sometimes we can means it is also see in it is also feasible to see in another way, where we are doing the document partitioning in vertical way. So that is vertical way. So for every document we are calculating the total numbers of terms available, and these all execute means the computation that can so it should not limit to one system, but we can distribute it thoroughly, and we can run it in concurrent fashion with different machines. So that is the core idea about utilizing the same IR concept under mapping and reducing environment, so that we can provide more scalability for the overall computation. Now I am coming to the next feature of Hadoop, that is Hadoop distributed file system. So idea is, I think, clear, but I can simply explain. So Hadoop distributed systems are basically Java based distributed file systems. So it allows us to break any large storage data, means any large data storage among multiple nodes in a Hadoop cluster. So suppose if we need to store 10 terabytes of data in any repository, and if we are not having 10 terabytes available at once, what we can do, we can scale it with 10 machines of 1 terabyte. So in this way, we can take the commodity hardware under use, and we can means the Hadoop distributed file system will keep track of each part of your storage, and it will provide you an access to different nodes, so that virtually it will feel like your data is available at once at one place, but actually physically the data is available on multiple nodes which you have created as to form the particular cluster. So this is this is the features of Hadoop distributed file system. And in information retrieval task, this distributed storage is really going to help us a lot, because we can understand that we are working with huge repositories for various purposes. So it is supporting the distributed storage first, and then the another thing is it is also supporting us for parallel computation. So parallel computation means suppose we are running a task with one machine in 43 seconds. So let us divide the task in such a way so that we can minimize our execution time. So suppose if we are going to use 10 machines of same capacity, so maybe that same task, if it is parallelizable in nature, can be run quickly, maybe in 4.3 seconds. So basically this is the way. So irrespective of using one machine, we can use 10 machines, and each machine can serve the purpose for the execution. So that is also managed by the Hadoop distributed file system. So what I want to say here, like scalability is one of the very prime requirement of any information retrieval systems, where we want to include more, and means we want to grow the more and more repository. So for that we can use the Hadoop distributed file systems. So as you know that there are two types of scalability possible. One is the vertical scalability, and second is the horizontal scalability. Vertical scalability means we are using one machine and we are trying to increase its storage capacity and more RAM and something like that. And you know that there is a limitation of you having the vertical scalability. We cannot add more and more RAM after certain extent. But horizontal scalability is limitless. So the only thing is you have to be prepared for the overall environmental management, means overall management of all the clusters or nodes. But rest it is open for any up to any extent. So scalability can be managed very well if we are using the horizontal scalability. So with the help of Hadoop distributed file systems, we can have scalability up to the maximum extent. Then rest part, I think it is very clear, like for managing all those, it is keeping the nodes under two category. One is the master node. So master node is a kind of coordinator, you can say. So it is managing all the slave nodes. And master node is having the master files, you can say. So it is having all the naming conventional details available. And these naming conventionals details are actually managed for the various workers or the name nodes. And the workers or the name nodes are actually doing the basic task. So this is the way how we process in the particular way. So, okay, I am going further to explain some of the other IR concern. Like everyone is looking for reliability part. Like if we are searching certain documents, or if we are doing some processing, we don't want to miss any of our observations. So how this means reliability can be ensured. So actually HDFS is keeping some inbuilt features for all such expectation. So suppose there are three files which we have basically managed here under different distributed nodes. So you can say that it is repeated distribution. So you can see the blue file here, here, and here also. Similarly, you can see this yellow split here and here and here. And similarly for this one. So basically, what I want to say, there is a inbuilt feature of doing replication more and more. So this replication can help us whenever there is any node which is down, whenever there is a power failure case, and whenever there are some other faults. So for that purpose, these are the some of the precautionary measures which are already available as a default working arrangement of Hadoop HDFS. So that we can do. Now I am moving ahead with some further support which can be taken from the Hadoop environment, that is Hive. So Hive, suppose if we are dealing with the distributed, suppose if we are dealing with the structured data. So for the structured data, the Hive can help us. It is basically an ETL tool, means it provides extraction, transformation, and loading kind of support, which is typically required in any data management projects or in any information retrieval projects. And it provides us an SQL like interface, so we can write all our intelligent queries over there and we can see the results accordingly. And these queries can serve the purpose in terms of mapping with all the individual resources and to ensure better and better scalability. So basically this Hive works on the top of the HDFS. So basically it provides us a schema for query writing. So we can have two types of working. One is the local mode and second is the map reduce mode. So in whatever mode we want, we can write all our queries. And if we are working in a map reduce mode, so the same queries can run parallelly, so that we can get the enhanced performance for the large scale processing requirements. Okay, so there are many benefits, like it supports scalability, flexibility, it is cost efficient, all the security and reliability aspects are well addressed, and it is going to increase our workability. And they are typically low overhead kind of systems because they are already prepared for these kind of expectation. Okay, so these are the limitations of Apache Hive. So limitations, although not very relevant, means here, because we can almost run different types of queries which are possible here. So this is the features of Hive which we can utilize. Now I am coming to the next part, that is the Flume. So basically this Flume, as I have told you, like there was a data at rest and now data in motion. So if we are considering the situation where data is at rest, so HDFS kind of situations are good, where you can keep your data in multiple files, maybe in a static way. But sometimes the data is altogether not available to us, but we are managing it through some dynamic sources. So for that, the Flume will work. So Flume is for collection, aggregation, and transportation of large amount of streaming data. It can be any log files, any event details, any network traffic, any social media data, or any email messages. And finally, this Flume will take the help of HDFS for certain operations. But how much it is means uh, taking the help of hdfs, you can see with this help, with the help of this diagram. So suppose you are expecting some web data or web documents which is generated by a web server. So it is a continuous generation, it is a dynamic generation, and it is coming to us. So what we need to do, we need little time to manage all those things, and that can be managed with the help of sources and channels and sync. So basically, source, channel, and sync, these are the three buffer kind of thing, you can say. And this, with the help of this buffer, we can manage the whole pipe. So the source is to accept all the data in terms of incoming streaming, and that the data can be stored in a channel for a very small fraction of time. And channel is a kind of buffer, and it help us not only to create some temporary storage, but also it help us to do some of the very basic operations if and when required. And there is a sync, and the sync will be basically preparing that data for the hdfs format as per our use. So this is basically the flow which we can use for creation of some dynamic data, means for the accessing certain dynamic data. Okay, so now I am coming to the another aspects. So Elasticsearch is dedicated for information retrieval processes. So basically, it is a kind of search platform. But uh, mm, uh, sometimes what we see, like Elasticsearch can be useful, but sometimes it lacks the distributed processing. So for that particular area, we can use more these Hadoop ecosystem features to make it distributed and to make it more parallelizable. So it is, if we talk about this Elasticsearch, so it is a very simple, scalable, open source, full text search engine, and we can refer big volumes of data in real time fashion. So actually it is not real time, but maybe with some time lag, so you can use the word near real time. Okay, and it is having very complex search features, and through the proper support of hdfs, it provides us distributed environment for the search engine. Okay, so there are various advantages of using Elasticsearch on the top of the hdfs, that is scalability, speed, and basically it is having a very capable apis for the various operations, and the best part, it is multilingual. So it supports search in different languages also. And mm, uh, s- uh, and it is, the best part is basically it is schema free, so it accepts the semi structured documents like JSON document, and then it can make the data more searchable with the help of this particular feature. There are other supporting tools also which can be utilized as a information retrieval feature. One is the Kibana. So basically, Kibana is visualization platform. So whatever we prepare, means whatever results we extract from the Elasticsearch, by efficient integration, we can show it in terms of very interactive way, that through visualization. So Kibana is a visualization tool, and uh, Kibana, along with Elasticsearch, can help us for all the possible interact means instances. Like it can provide us searching operation, it can provide us viewing operation, and it can also provide various way of interaction with the data stored. Okay, and the visualization patterns can be full of variety, like we can show the charts, tables, and distribute and dashboards, means dynamic dashboards for these particular purposes. And you can see that these three features, they are always worked together to represent the various insights of the information retrieval. They needs very less or maybe minimal programming effort. So basically they are full of what you can say, that the templates are ready, templates are available. With very small scripts, you may able to perform various operations, maybe creation of interactive charts, and efficient using of aggregation filters and some very ready-made kind of dashboards we can prepare. So basically they are very quick in terms of learning or in terms of understanding. Now I am coming to the backend part. So these are the features which are more towards the user side, means users are interested to see all these results. But uh, being a overall responsible means as a overall responsibility, there are certain backend tasks which are equally important. So basically Apache Zookeeper is one support for that. So basically this Zookeeper is responsible for all cluster arrangements. So cluster arrangement means the number of nodes within the cluster, configuration management, and some kind of synchronization. So that is possible with the Apache Spark. And with the help of this, we can work on various operations. uh, Now I am coming to the because we have very limited time, so I am coming to the other part, that is the RDD creation part, which is in map Spark. So as I told you, like that was one part, like how to work with data at rest. And now suppose if we are working separately for data in motion kind of paradigm, so Apache Spark will be the best tool. So this Apache Spark is actually a cluster computing environment where we have interactive queries, and this interactive queries through some stream processing engine we can perform. So uh, I can show you some means evaluation, like how from Hadoop we are moving towards Spark with the help of this particular diagram. So in Hadoop you can see that there is a time lag. So whatever is happening here means whatever input data we are providing here, it can be processed with little delay. It is all symbolic diagram, but it can show you there is a time lag. So it is basically not in a real time fashion. So but when we talk about the streaming data, so most of the time users are willing to work in a real time fashion. There is no delay which is means permissible. So Spark is for that kind of environment. So whatever processing you are doing, suppose means it is a kind of Twitter media analytics, to Twitter data analytics. So immediately, suppose at any moment of time you want to see the means highly rated highly tweeted any comments or any most liked pictures and all. So basically it can give you the correct picture of any particular timestamp. So this is basically the real time processing which we can highlight with the help of Spark. So there are some of other comparison parameters, although we can leave it here because I am going to share the slides to you all so you can see it there. So but one thing I can very much stress, like is Hadoop MapReduce, it is only for the batch processing. So it is not means applicable for the streaming information retrieval processes. But with the help of Spark, we can run if there is a batch kind of situation, we can run if there is a real time needs, if we can run if it is an interactive or interactive kind of mechanism, and we can also support it with the help of some graphical representation. So basically this is the benefits which we can get through Spark in terms of information retrieval. So if I talk about the core components of Apache Spark, so basically there are different components. So you can see that again in case of Spark, it is fully supported by SQL features. It is fully supported by streaming features. It is having machine learning libraries. So at the top of the information retrieval task, if we can show our results under certain specific needs, so we can run it with machine learning libraries. So and it is having all the basic supports, like it is having the cluster manager, and it is having the processing engine and scheduler. So basically the Spark components are uh, basically they are rich in terms of all kind of possible support. Now I can go through with one important parameter. The question is, since it is a streaming data, So how we see the means the document or the file which we are processing. So here there is a special way of processing the streaming data, and that is known as RDD. So basically RDD is resilient distributed databases. So that's why here what we see here, we see that whatever data we are receiving, if it is coming from distributed sources, so it is important to take them as per their arrival. So it is also important to take them as per their uh, means structure, you can say that. So their formats are also important. So basically RDDs are really made for this. So RDDs can be created from the various data sources. So it provides a abstract data representation or data structure, and this is very well suited for Apache Spark kind of ecosystems. So it is basically a way of taking data for further processing. So they are having a very different kind of data structure, and it is known as RDD. So any file which we handle over Spark is known as RDD file. And whatever operations we perform, actually it is divided into two parts. One is the transformation operation, and second is the action operation. So transformation operations are those operations which basically means it is a kind of transformation function. So if we want to restructure, if we want to select something, so if we want to filter something, so these kind of operations are transformation operation. So all these kind of IR steps, which are very means they are the integral part, so we can perform as a transformation operation. Then there may be few actual logical kind of operations. So these logical kind of operations can be taken under action part. So basically the first task is to create an RDD, and then next task is to follow the transformation function and action function over the data, and finally we can come up with the results which are the means actionable data. So let us have the more detailed information about RDD. So RDD is resilient distributed data sets. Okay, and basically it is a collection of anything which we are getting for further processing. So suppose if we are getting means real time streams, streams are nothing but certain set of strings. So these strings can be grouped in terms of RDDs. So RDD of strings, you can see, so it is basically immutable collection of objects. Here objects are nothing but the streams that can be partitioned. And how it can be partitioned? Because there are various windowing criteria we are going to assume, and there may be they are coming from varied sources, so there are certain natural criteria of doing the partition. It can be distributed means we can take them to various execution nodes, and it can be stored in main memory, and basically it can partitioned in such a way so that it can also handle any situation like failures. So basically that is the purpose of creation of RDD. So every data or every document which we are receiving for in-memory computation over this Spark platform, we are assuming that they are the part of RDDs. So basically we perform two types of operations. One is the transformation operation, and second is the action operation. Okay, so you can see the list of transformation operations and action operations here. And basically the transfer operations are map, and I can show you the details here. Let us see. So mapping is nothing but we can update any of the data elements under certain constraints. So suppose we want to multiply these data elements by 2, so that can be done here with the help of map function. Similarly, filter operations can be done. So filter operation, suppose we want to use some modulus operator for the filter operation, so that is also possible. And then suppose we want to take some distinct values, so distinct values can be taken out of these data elements. We can take the distinct values, so every time it can be taken the distinct values. And then there is a flat map. So basically we want to see how many numbers are occurring here and what may be their uh, means further mapping function. So here mapping function is nothing but power of 2. So basically we are taking every number with the mapping function, and that is basically the flat map. So in this way we are updating whatever data we have as per our constraints. Okay, and similarly you can see the reduce function. So reduce function is nothing but to aggregate elements in the RDD. So basically it can take two or more arguments and it can return the one. So suppose these are the data, and as a reduce function we are taking the multiplication of all this, so it is coming as 6. So this is basically the reduce of functions. Then we have the take operation. So take operation may it can like a pruning kind of thing. So pruning can be done. So we want only two data elements, so it can be taken as 2 here. Then we have the collect operation. So collect operation means we can collect maybe all, we can collect maybe first 5, we can collect maybe first 100. So basically it is just taking a subset from the available data element. So this is the way how, and you would be happy to know like all these processings are real time processing, and it is happening in in memory computational platform. So they are basically, nothing is going to store in your secondary device, but it is basically utilizing the main memory of your system to react immediately with the latency of fractions of microseconds. Okay, similarly the take ordered may be one action operation. So here we are taking some numbers with in certain order. So order may be descending order as indicated here. So these are basically various operations which we can perform through through Spark RDD files. Okay, and what next we can get here, like as I told you already, like if we are dealing with the information retrieval task which is of streaming in nature, so definitely we need to restrict our observation with the help of windows. So Apache Spark is giving us all windows related operations. For example, you can decide the type of window, we can decide the count of window, we can decide the sliding parameters for that particular window. So basically these are like window length, sliding intervals, these things can be decided, means we can set. So there are basically options available, and we can set our stream characteristics with the help of these settings. There are various way to set, like what kind of window length, what kind of window type we want to manage, so that can be managed. Then other aspects which is there, like there are mlib libraries. So in Spark mlib libraries you can do many of the supporting tasks, like all pre-processing can be done. You can see that here, like there is a featureization library. So with the help of this featureization library, you can have all feature extraction techniques. So here it is having inbuilt library for calculating this means all the text mining aspects we can perform here. So with the help of featureization we can do the transformation part, dimensionality reduction part, etc. And there are the pipeline tools also available. So these pipeline tools are helping us to efficiently control these streaming operations. Okay, other than this, if we go for the ML algorithms, so these ML algorithms are having most of the implementation of classification, regression, and clustering tasks. And especially there are certain well-defined methods are available for collaborative filtering, and all these are having the consideration of data stream, so that can be possible here. So even we can use this TF IDF using PySpark. So basically we need to calculate the number of terms, the number of unique terms, or the number of documents, the number of occurrence of every term in every document. So these all can be possible. So basically this is the snapshot which I have taken for the implementation part. So we can take the data set in terms of RDD, and RDD is nothing but it is a very abstract level of data representation, whatever we are getting. And finally, we have to see that tuples of key value pair, where the key is the document ID and value is the content which is inside the document. Then we are having the mapping of the key value pairs to the new key value pairs. So you can see that here we are generating the mapping function. So there are, means basically there is a mapping function. So every, for every with word, these are the uh, basically we are calculating the mapping of key value pairs. Then finally we can have the reduce function, so reducing the key value pairs, and it is counting all those aspects, and if it is required we can perform the final mapping. So this is the way how we calculate the term frequency. Okay. And then in the similar way we can calculate the inverse document frequency. So mapping and remapping can be done as per the formula. And you can say that this all these means tasks, they are highly scalable among the cluster which is available overhead over there. And finally we can compute the inverse document frequency, and with the help of some small script you can see that we can calculate the inverse document frequency, which is already shown with the help of these. I can show you the video also at the end of this lecture, so you can see how it is calculating. So basically there are, I mean, basically these RDTs are efficient enough to provide all basic functions, like it can provide the inner join, it can provide the multiplication, it can provide the full visualization support where we can see the results in terms of PySpark data frames. So this is the way how we can see the TF-ID TF-IDF with the help of PySpark. There is one thing which I can highlight at the last, that is limitation of Apache Spark. So basically, if we talk about the limitation of Apache Spark, so I can say that although it is claiming that it is real time, but still there may be more interactive processing which is possible, and there may be rich graph processing can be possible. There are means more powerful distributed options can be explored. So basically Apache Flink is established as a better option as compared to Apache Spark. So what they are doing here actually means, what is the upgrade thing? So here the one upgradation is basically they are doing the information retrieval is on the event driven applications. So event driven applications means everything is completely dynamic. Whatever data or document or reports they are generating, it is thoroughly generating in a real time fashion, and even the structure is completely purely dynamic, and we are having no idea in terms of their occurrence pattern or their formats and all. So basically if this is the case where we are dealing with the information retrieval of event driven applications, for these cases Apache Spark is really a good way to manage. Then other than this, it is having all the possibilities or all the features which we have already seen. So it is including the features of streaming pipeline, and it is also including the features of batch processing. So basically it is having the key characteristics which we can explore through Hadoop distributed file systems, and it is having the importance of all the Spark features. So Apache Flink is something which is more you can say that advancement over the big data information retrieval platforms. One example of these means evaluation or these improvement is in terms of architecture. So basically Apache Flink is using Kappa architecture. So the Kappa architecture is the architecture where only the streams can be used for processing. But Hadoop and Spark, they are using the Lambda architecture. So where we can do the batch processing and micro of the means micro batches. So what you can, I can conclude here, like if we say like Apache Flink is a truly streaming platform, and Apache Spark is a streaming platform with some limitations, so that would not be very surprising. So So basically, Apache Spark is more strong because of its Kappa architecture, and it is a truly streaming platform where we can run one element at a time without need of any micro batch or without need of any partial batch processing environment. Then the second important thing is the iterative processes are better optimized in Flink. So many times there is a possibility like we want to repeat more, repeat same process again and again for better results. So all kind of optimizations like this can be efficiently handled by using the Apache Flink. Okay, then there are some other observations like both Flink and Spark are general purpose platform, but Hadoop and Spark can handle the batches also. And Flink can also be handle some kind of batches, but its core task is towards the streaming part. Okay, so basically these are the important features of Apache Flink that can be utilized is as a one of the very powerful platform for information retrieval. So you can see all the possible features which we have which we can expect with any information retrieval framework is already available here. So it is showing us full support for the storage aspect. So for the storage, we can store individual files, we can store databases, and we can store streams. So basically Flume and Kafka, these are for the streaming storage. MongoDB HBase SQL is for the database storage, and HDFS along with some other local file systems can be for the individual file storage. Similarly, if we go for the other processing environment, so it is providing the local processing environment through Java virtual machine. It is providing the clustering environment through standalone Yarn, Musos, and Tej. So basically they are the cluster managers, we can say. And it is also supporting the cloud related means processing for the larger data sets. Then if we talk about the core of the execution, so they are having the streaming data flow platform. So any task which is sensitive for the streaming operations will be efficiently managed under this particular set. And Flink is very rich in terms of APIs also. So basically there are two sets of API. One is the data set API, which is for batch processing, and second is the stream processing API. So this is for thoroughly the stream processing. At the top of it, you can see there is a Flink ML library. So Flink ML library can support all machine learning and related pre-processing details. And there is a Jelly is for the visualization purpose. So whatever information we extract, if we want to show it with some better dashboard, so that can be supported with the help of Jelly. Then it is having the structural representation through tables, and basically all possible options starting from data collection, aggregation, then distributed implementations, then database management, everything it is supported by the Apache Flink ecosystems. And the another thing is, as we have already understood, Apache Flink is also working on two modes. One is the master mode and second is the slave mode. So all the basically the job managers, they work on the master mode, and then there are slave mode operations. So basically the task can work on the slave mode. And if we talk about the overall benefits of using Spark and Flink ecosystems for information retrieval purpose, so they all are of high performance, so they can support real-time processing, and they are very good in terms of high throughput. They all are low latency applications. Even Flink is the best in this out of all this. So it can process the data without any delay actually. Then it is basically an event processing engine, so it support stream processing and windowing on the basis of various events. They may cause means they may cause the generation of these streams. So basically this is basically event processing engine. Then it is very fast in terms of data speed, you can say that. So basically of whatever velocity aspects which are critical, it is manageable through the flinks. Then fault tolerant features are already available, so any kind of failure of hardware, failure of nodes, any kind of data loss can be handled with the help of fault tolerance mechanism, which is already there. We have already seen like how the replica is something which is very common while dealing with these flink features. Then there are more memory management aspects. So memory management aspects means most of the computation which we are doing in memory. So it is having some aspects like we can decide the size of the cache as per our need, and basically we can customize the even the scripts can be customized in terms of dynamic allocation of the memories. So then we have finally the integration of all those features under one interface. So basically all resource management along with reporting mechanism along with data ingestion tool, everything is integrated by using one common interface. It is also scalable. So whenever we are having some scalability requirement, we may simply include one more cluster, and it is having full set of operators. So all set of operators along with their basic functionality, we have seen that it is having very rich RDD related functions, so that can be easily implementation possible. Then we have certain uh, other aspects like better management of streaming and all. It can be easily possible with the help of links. So I can show you some other details like how to means execute the application in Flink. So basically, we need to first write an application program. So that application program has to be written, and inside it is going to run with the parsers and type extractors, and certain optimization things are there. Then basically the core task is nothing but to manage it at the task level and at the basically the master level, where we divide the task in terms of various worker nodes. And to have better scalability, it divides the job in terms of various data flow graphs. So basically these are the things which we can process while doing it. What I can do here, I can give you a short picture, maybe for just to understand the whole thing. So basically, you see, like in any typical information retrieval task, we do some pre-processing. So the starting of means the support of Hadoop distributed environment is available at this stage also. So whenever you are talking about the crawling part, so we have Kafka, we have Flume, and these Kafka, Flume, and Scoop, they are very strongly available tools for the crawling purpose. If we talk about the pre-processing part, so if this pre-processing is related to the streaming, it is available in the Kafka and Flume. And if the pre-processing may be for some further management like data transformation, so for that we have HDFS. So HDFS is going to help us for basic data management as well as some kind of topic modeling. So this can be done with the help of HDFS. HDFS after this HDFS, if we go for some other extended available tools, maybe Spark or Flink, TF-IDF can be implemented over, means it can be implemented there, where we can calculate the TF-IDF in any aspects, maybe in the batch processing way, maybe in the complete real-time way. Both aspects are available. If we go for the visualization part, so there are several machine learning libraries available. You can visualize that your findings with the help of either clustering, classification, or there are various options of interactive dashboards that can also support us for efficient visualization purpose. Okay, so as far as the visualization is concerned, so we have in Flink, we have Jelly, and even in Spark, there are graphics and there are other visualization libraries available, and they will help us for various visualization related expectations. So these are the various things which I can see here, and I will take 2 minutes to share one video. So I think let me share that video here, and then we can proceed further.
Yeah, so I think this video is not having any audio, I hope. Yes, ma'am? Yeah, because we are not getting any audio input along with video. So that's okay because it is directly shared. Ma'am, okay, so if you are facing any problem while while playing this video with audio, so we can we can leave it here. That is up to you, ma'am. So yes. So I think we are done with the session, and we've done with the discussions which we have planned. And now we have got few questions. Most of the questions has been maybe addressed during the discussion. So we have got a few questions like one of the question by your participant is that deep learning techniques, or is deep learning possible with Spark or Flink? Ma'am, your audio is not available to us. Yeah, still it's not with us, ma'am. Unable to hear you, ma'am. Maybe because system. Yeah, system is showing something else. I mean, system is showing. Okay, maybe ma'am is connecting again. So let's wait for. Yeah, yes, ma'am. So need to unmute yourself, ma'am. Please unmute yourself.
Okay,
Yeah,
fine.
it's fine
Is
now.
it okay? Okay.
It's fine.
So,
It's fine.
okay,
Yes.
since I reconnected, so I lost all the questions. Can you repeat the questions again so we
Yeah,
can?
the question was like, can we? I mean, is it possible to use deep learning with Spark and Flink?
Yeah, Flink it is not available, but in Spark it was, there was one blog which was published in 2018. So now onwards people are working deep learning with Spark, so it is available. Not very stable version, but there are some GitHub repositories available, and we can start working from that.
Right. So I mean, there is a similar question, right? Like, can Hadoop integrate both Kibana and Apache? So I think these are the fundamental questions. Yeah. Yes, ma'am.
Yeah, definitely. Basically, Hadoop ecosystem is a very large ecosystem, and they are giving a kind of package. So all these are already available. So some they are having some repeated means overlapping features also. So it is up to us like what kind of features we want to explore with what kind of component.
Great. So now I request participants to raise their questions if they are having. They can enable audio and directly share the questions if we have. Yeah, so I think, ma'am, we have done with most of the questions, and the whole discussion was, I mean, it was like extensive and the details, and that too, because we have touched upon the stream data and its different aspects of how to prepare our infrastructure, computing infrastructure for that stream data, and achieving some kind of information retrieval on that. So it has been extensive and it has been in proper details. So I would like to thanks from the department side, and along with it, I want to share our greetings from the participant side also for sharing these kind of details with us. It is always privilege to listening to you, because we are having very limited resources for who are working on stream data. So it is it's a opportunity always. So thank you for that, ma'am.
No, I actually I was looking. There was very good questions on that is part. So,
Yes.
anyways, if anybody wants to get further interactions, or he or she can write to me, I will share my slides, videos, and everything. So,
Yes.
so I would be happy to have further interactions with all the participants. So, thank you very much for giving me this opportunity, and all the
Great.
best for all your research journey.
Yeah.
Thank
So,
you.
yes. Thank you, ma'am. Thank you. Thank you very much. Yeah, so I think we have just got one question. So we will take this question like we use millions of documents at the same time. So we have to create that much worker nodes in MapReduce. Then how we will cope with this? So I think this question we will take in some of the upcoming sessions. All right. So with this remark, I want to conclude this session, and let's join for the next session, which is session 3, and it will be covered by Dr. Uh, one of the professor from the IIT Rupert. So it will be again. So now we are going towards the intended direction, right? Because now this whole FDP is planned it in a way how we can plan our how can design our information retrieval process or a system by keeping user in loop, by keeping human in loop. So from the next session onwards, we will be basically moving towards that direction, like how to capture the user presence in retrieval part. So to this next session will be for that purpose, and after that we will be having different sessions by keeping that direction or dimension or aspect into it. So thank you for joining this session. Let's hope we will be there in the session 3 by 3 p.m. Thank you very much. Thank you.